Welcome back to History for Sleep. Today, we will dive into the history of candles and light. Light in human life begins long before any lamp or candle. It begins with daylight, with the slow arc of the sun, and with the changing length of shadows across stone and soil. For most of human time, the bright hours and the dark hours were simple facts of the world. Work gathered itself into the day. Rest gathered itself into the night. In the dim hours, the clearest light was usually the oldest kind, the small, steady glow of fire. A fire is not only warmth, it is also a moving edge of visibility. It makes a circle on the ground. It makes faces and hands appear, then disappear, then appear again. It turns a piece of night into a place that feels shaped. Early lighting was often the same as early heating. A hearth or an open flame did both. It did not travel easily, and it did not focus into a narrow beam. It was bright nearby, and weak a little farther away. A room could be warm, and still be hard to see in, beyond the line of the flames. From that wide, shared light of a fire, many older lighting tools can be understood as ways of carrying a smaller flame, or feeding it more carefully, or protecting it from wind. In many places, the simplest portable light was a piece of burning wood held in the hand or wedged into a wall. A torch is simple to imagine, and it belongs to many times and places because it is made from materials that can be found almost anywhere. Over time, many communities turned to lamps that used liquid fuel because liquid fuel could be carried, measured, and replenished. A lamp could be left burning while attention drifted elsewhere, as long as the flame remained safe and the fuel lasted. In the ancient Mediterranean and surrounding regions, pottery lamps became common very early. Some of the oldest forms were like shallow bowls, filled with oil, with a wick resting near the rim. Later, shapes pinched the rim into a spout, so the wick could sit more neatly, and the flame could be steadier. The fuel was often a plant oil, and in many Mediterranean contexts it was olive oil. The wick might be linen, papyrus, or other fibers that could draw oil upward through capillary action, feeding the flame slowly. Some collections describe this gradual development from simple bowl to pinched wick support as a long practical story told in clay. The lamp in these forms becomes a small machine made of earth, oil, fiber, and air. In some regions, lamps took other shapes and used other oils. Museum descriptions of lamps from Egypt and late antiquity, for example, often mention castor or sesame oil in the reservoir, and plant fiber or linen wicks. The same basic principle remains, a wick drawing fuel toward a flame, and the lamp body shaping how the fuel sits and how the flame is held. In this older world of lamplight, the brightness of a single flame could be modest, but the value of that modest light was large. It extended time. It supported reading, writing, weaving, mending, cooking, prayer, and quiet conversation. It also made movement safer, simply by making the next step visible. Candles belong to the same long search for manageable flame, but they do something different from an oil lamp. An oil lamp keeps a pool of fuel and feeds it to the wick. A candle turns the fuel into a solid form and then uses heat to melt a little of that solid into liquid, right where the wick can draw it up. In that sense, a candle carries its own fuel in its body. It is a small column of stored light, a controlled reserve that can be moved from place to place. Candle-like devices appear early in the archaeological and historical record, but the true candle, with a wick embedded in a solid fuel, has a clearer path in the sources. Encyclopaedia Britannica describes ancient artifacts resembling candlesticks from places like Egypt and Crete by around the 3rd millennium BCE. And it also notes that ancient Egyptians made rushlights by soaking the pith of reeds in melted animal fat, though those rushlights lacked the same kind of built-in wick that later candles used. A rushlight is a quiet cousin of the candle. It is made by taking a dried rush, stripping it down so that a pale core remains, and then soaking or dipping that core in fat or grease. When lit, the rushlight burns with a small flame. Britannica notes that rush wicks were used in ancient Rome, and that rushlights may be older than true candles, and that they remained in use in England into the late 19th century. They were inexpensive, and they fit into the homes of people who needed light without spending much for it. When candles became more standardized, materials mattered. In Europe, for long periods, a great many candles were made from tallow, rendered animal fat. Tallow candles could be made in quantity, and they provided necessary light, but they could also smoke, smell strong, and soften in warm weather. Beeswax candles were different. Beeswax tends to burn more cleanly, with less smoke, and with a steadier, often brighter flame. It also carried social meaning, because it was usually more expensive. In many medieval and early modern contexts, beeswax candles were associated with churches and wealthier households, while tallow was associated with the everyday needs of most homes. Britannica describes the Romans as developing true wicked candles by dipping rolled papyrus into melted tallow or beeswax, creating portable light sources. That image is simple and practical. A wick, formed from plant material, is coated again and again until a body of fuel forms around it. As candles became a craft, they became part of urban economies. In medieval Europe, candle making was a trade, and in some cities it was a guild craft, organized and regulated. The word chandler survives from that world, attached to candle making and to the shops that sold light, among other necessary goods. Guild systems helped control quality, weights, and prices, because candles were not only decorative, they were infrastructure. They were daily time, measured in flame. In London, wax chandlers and tallow chandlers became distinct groups, with different materials, different customers, and different standards. Ordinances and rules aimed to protect buyers from adulterated wax or underweight candles. Even in those regulations, the purpose is quietly visible. A candle that burns too fast, or smokes too much, or fails early, changes the rhythm of an evening. The candle also depends on its wick, and the wick has its own long story. In many older candles, wicks needed attention as they burned. The burning tip of the wick could grow long, charred, and smoky. To keep the flame clean, the wick had to be trimmed. This trimming could be done with special scissors, sometimes combined with a small box to catch the clipped, burned fragments. A museum discussion of candlewick trimming describes how, until the first half of the 19th century, trimming was a regular part of candle use, not an occasional detail. In wealthier homes, candle tools could be ornate. In more modest homes, the tools could be plain. The function remained the same, keeping the flame steady and limiting smoke. The candle, in that moment, is not just a passive object. It is part of a small routine of maintenance. Over the 19th century, wicks changed in ways that reduced this need. Braided cotton wicks, designed to curl as they burned, could bring their own tips into the hotter part of the flame, so the charred portion burned off more completely. The self-trimming wick became one of those quiet improvements that many people might not notice in the moment, but that slowly altered daily life. making candlelight a little simpler and cleaner. Materials, too, changed. For many centuries, beeswax and tallow remained important. But from the 18th century into the 19th, other waxes and fats entered candle making, especially those that offered brighter and cleaner burning. One of these was spermaceti, a waxy substance that was used historically in high-quality candles. In the United Kingdom, candle-based standards of light measurement would later refer to a spermaceti candle in legal definitions of candle power, tying the language of brightness to a particular kind of candle and a particular kind of material. Another shift came through chemistry. In the early 19th century, chemists studied fats and learned how to separate and purify components. A well-known figure here is Michel Eugène Chevreul, associated with work on fatty acids and with the development of stearin or stearic acid candles, which were harder and tended to burn more cleanly than simple tallow candles. Stearin candles and later paraffin wax candles would reshape the candle industry because they made candles more uniform, more affordable, and in many cases more pleasant to burn. Paraffin wax itself belongs to the world of refined fuels and industrial processes. Encyclopaedia Britannica describes paraffin wax as a mixture of solid hydrocarbons obtained from petroleum by dewaxing light, lubricating oil stocks used in candles and many other products. Other historical accounts describe the discovery and isolation of paraffin in the 19th century, associated with chemists like Karl Reichenbach and with the wider growth of industrial chemistry and refining. In these changes, there is a gentle pattern. A household's light, once bound closely to animals, bees, and local agriculture, becomes increasingly bound to mines, refineries, and chemical plants. The flame remains familiar, but the path from source to candle becomes longer, more distant, and more industrial. While candles were evolving, so were lamps. Oil lamps continued to change, and one of the most influential improvements came in the late 18th century with the Argand lamp. The Argand lamp used a cylindrical wick rather than a flat one, and it arranged airflow so that oxygen could reach the flame more effectively. With a glass chimney to steady the draft, the lamp burned brighter and more cleanly than many earlier oil lamps. French cultural heritage descriptions of the Argand lamp emphasize how, before such improvements, the light from many home oil lamps could be thin and smoky, and how the Argand design offered a steadier, brighter flame. This kind of lamp, brighter and cleaner, supported new habits. Reading in the evening became easier. Fine work could continue later. Indoor spaces could be used with more precision. Light here is not only more hours, it is also a different quality of attention. Around the same time, lanterns remained important. A lantern is, in a simple sense, a shelter for a flame. It protects a candle or lamp from wind, and it reduces the risk of accidental contact. Lanterns can be made from metal and glass, or from other materials suited to local practice. In cities and in rural paths, lanterns made movement in the dark more manageable. In East Asia, lantern traditions developed with their own rich forms and meanings. Paper lanterns, with frames of bamboo or wood and coverings of paper or silk, could diffuse light softly, turning a flame into a warm, even glow. Historical writing on paper lanterns connects them to Chinese poetic references and to periods when lantern festivals became established. In Japan, lantern forms such as choshan became part of streets, shops, and temples for centuries, later adapting to electric light while keeping the same gentle shape. A lantern, whether glass or paper, changes the behavior of light. It spreads it. It softens it. It also makes the flame less directly visible, turning the sharp brightness of fire into something calmer. As the 18th century turned into the 19th, large changes approached, especially in cities. Gaslighting became a major competitor to candles and oil lamps. Coal gas could be produced and distributed through pipes. In streets, gas lamps created a new kind of public nighttime. Smithsonian histories of 19th century lighting describe how gas streetlights went into service in the early 19th century in American cities, and how gas lighting became mature and well established by the time electric incandescent systems arrived later in the century. A gaslit street had a different rhythm from a candlelit home. It was not dependent on each household carrying and protecting its own flame. It was managed by companies, by municipal authorities, and by workers who maintained lamps and pipes. The city's night became more uniform, more planned. Gaslighting also changed interior spaces. Homes and businesses could have steady flames without the daily handling of candles. But gas systems brought their own concerns, including air quality issues from combustion and the practical need for careful maintenance. At the same time, new liquid fuels were changing lamps again. In the mid-19th century, kerosene became important. A museum account of the kerosene lamp describes Abraham Gesner's work in distilling coal to produce a clear fuel that could burn with a bright flame, offering an alternative to earlier lamp fuels. Kerosene, later often derived from petroleum, became widely used in lamps designed with glass chimneys and controlled drafts, making household lighting brighter and more reliable for many people. This period can feel in retrospect like a layering of options. Candles are still used. Oil lamps still glow. Gas lights spread through many cities. Kerosene lamps enter homes and shops. Light becomes a field of competing technologies, each with its own costs, convenience, and social meaning. And then electricity begins to turn from experiment into system. Electric light has its own early demonstrations. Smithsonian material on 19th century preconditions notes Humphrey Davy's early 19th century experiments producing a powerful electric arc between charcoal rods, though these were not immediately practical. Later, as generators improved in the mid-19th century, arc lighting became more feasible. Arc lights were often bright, sometimes harsh, and suited to particular uses such as streets, large rooms, and industrial spaces. A museum object description of an arc lamp, like those designed and improved by 19th century instrument makers, belongs to this world of bright public illumination, sometimes dazzling compared to a candle. Incandescent lighting, the glow of a heated filament in a glass bulb, would become the domestic counterpart, warmer and steadier, more like a familiar flame in its softness, though very different in its mechanism. The US Department of Energy's history of the light bulb notes that long before Edison's patents, inventors demonstrated that electric light was possible, including arc lamps, and it places Edison's work in that wider context of experimentation and development. In Britain, Joseph Swan's incandescent experiments and installations were part of that same story, and in the United States, Edison's work became tightly connected to the building of a complete system, not only a bulb, but also generators, wiring, meters, and business models. In 1882, a milestone moment in centralized electric power for lighting is often associated with Pearl Street Station in New York. Engineering histories describe it as the first permanent central power station for supplying incandescent lighting, an effort meant to prove the practicality of a central station system. Smithsonian accounts of 19th century lighting promotion describe the same general event in practical terms: a site in the financial district, a switch thrown, a system beginning to deliver light to customers. it is possible to imagine, without any drama, how that felt in daily life. A room that had been arranged around windows and around a hearth could be rearranged around a switch and a fixture. A workshop that had depended on daylight and on careful use of flame could extend its hours more easily. Streets could grow brighter, and the boundary between day and night could soften. In many places, electricity did not replace everything at once. Gas remained. Kerosene remained. Candles remained. But the trend, especially in dense urban environments, moved toward electric lighting. The consequences, as Smithsonian histories observe, included older forms of lighting becoming more associated with special occasions or with emergencies rather than being the default for daily life. Meanwhile, the science of measuring light developed alongside the technologies of producing it. For a long time, brightness could be compared only by eye, with careful setups and agreed standards. The language of candle power reflects that older world, where a candle of defined material and burn rate could serve as a reference. Later, international standards moved toward the candela, the SI unit of luminous intensity. Professional discussions of this shift and the history of the candela trace how candle-based units were replaced by definitions linked to radiometric measurement and human visual response. An official SI documentation describes the candela in terms of a specified luminous efficacy at a given frequency. There is something quietly fitting in that. A candle, which once simply gave light, becomes part of the language used to define and compare many lights, even those that are not flames. As the 20th century progressed, electric lighting diversified. Incandescent bulbs improved with different filament materials and with better manufacturing. Electric discharge lamps developed along another path, with gases and phosphors producing light in tubes and bulbs. Britannica's discussions of lamp technology describe parts of this development, including the early 20th century appearance of neon lighting associated with figures like Georges Claude. Fluorescent lighting, later common in offices and factories, brought a different quality of illumination, broader and often cooler in tone. In public spaces, different kinds of discharge lighting, including high-pressure sodium and other systems, became important for streets and large areas, each with its own color and efficiency. Then, in the late 20th century and into the 21st, LEDs moved from indicators and small points of light into full illumination. The invention of efficient blue LEDs was a key step in making bright white LED light practical. The Nobel Prize in Physics in 2014 recognized this work as enabling energy-efficient white light sources, making long-lasting and efficient lamps more widely possible. This story, from flame to filament to diode, can be told as a story of efficiency and engineering. It can also be told as a story of atmosphere. Candles never truly disappear. Even as electric light becomes common, candles remain in rituals, in celebrations, in quiet domestic settings, and in moments when electric systems fail. A candle is small, but it carries a sense of immediacy. The flame is right there, visible, moving gently. The light has a warm color, and it falls off quickly with distance. It makes a small world, and it does not try to fill every corner. In homes before electric lighting, the hearth often held the strongest indoor light, and a science museum account of lighting the pre-electric home describes how activities revolved around that fire, with candlelight or oil lamps offering dim but mobile light elsewhere. It observes, in simple terms, how quickly light fades a short distance from a candle, and how that shaped what could be done. That older experience still survives in the presence of a single candle. A modern room, fully wired and bright, becomes something else when electric lights are turned off and a candle is lit. The walls recede. The ceiling becomes less important. The world returns to a circle. The materials of candles today can vary widely. Paraffin wax, stearin, beeswax, and many plant-based waxes are all used. Wicks can be braided cotton, sometimes with carefully chosen thickness and treatment so they burn steadily. Candle making can be industrial or artisanal, with different goals, from long-burning utility to scent and decoration. Even in the age of LEDs, the candle remains a kind of reference point. It is part of how brightness is described in everyday language and part of how warmth in a room is imagined. The flame is not only a light source, it is also an image of light itself, a moving symbol of visibility. In earlier centuries, candles and lamps were part of labor. They were part of the cost of doing work after dusk. They were part of household budgets and part of craft economies. They were stored, counted, protected from damp, kept away from drafts, kept away from accident. A candle could mark time, not only by the hourglass or the bell, but by its own burning length. A certain amount of wax or tallow could mean a certain span of evening. A household might decide how many candles could be used, and when, and for whom. In churches and ceremonial spaces, candles carried meanings beyond practicality, but even there, their physical qualities mattered. Beeswax, burning cleaner, could be preferred in certain settings. The steady flame could be part of long services, and the visual presence of multiple flames could turn a dark interior into a patterned field of light. In public streets, gas lamps and later electric lamps took on that role of patterned nighttime illumination. Rows of lights changed how people moved, how shops stayed open, how city evenings felt. In industrial spaces, bright arc lights and later powerful electric systems made night work more feasible, though not necessarily easier in every human sense. A brighter night can be a longer night. Still, the simplest unit remains the same. A flame, fed by fuel and air, held at a point, turning chemical energy into heat and light. In an oil lamp, the wick draws fuel upward from a reservoir. In a candle, the heat of the flame melts wax into a small pool, and the wick draws that liquid upward, where it vaporizes and burns. In both cases, the visible flame is only part of what is happening. Around it, heat rises, air flows, and the boundary between solid, liquid, and gas shifts in a quiet balance. A candle flame often has layers. Near the wick, fuel vapor rises. Around it, oxygen arrives. The light comes from excited particles in the flame and from tiny glowing soot particles, depending on the fuel and conditions. The details can be studied in laboratories, but the feeling remains plain and familiar. A candle does not need to be understood to be used. It only needs to be lit, and then watched, and then extinguished. In historical terms, candles and lamps also belong to trade routes and agriculture. Beeswax depends on hives, on flowering landscapes, on beekeeping knowledge. Tallow depends on animal husbandry and on the practical methods of rendering fat. Plant oils depend on crops, presses and storage. Paraffin depends on petroleum, on refining, on global supply chains. When a candle is held in the hand, these networks are not visible. The candle seems self-contained. But behind it, over centuries, there are landscapes and labor systems, shifting and expanding as technologies change. A pottery lamp in a museum can feel very still. It sits quietly behind glass. Yet it once held oil, and it once held a wick, and it once made a small circle of light in someone's evening. A candle stub, found in an old household inventory or described in a diary, can feel small and ordinary. Yet it once marked a portion of someone's time, and it once turned a corner of a room into a place where hands could work. A gas lamp on a 19th century street can seem like a piece of ironwork and glass. Yet it once tied a home's visibility to a municipal network of pipes and maintenance. An early incandescent bulb can seem like a delicate artifact with thin filament and glass. Yet it once represented a new promise of steady light without flame, a light that could be turned on and off with a small motion. A modern LED bulb can feel almost invisible in its complexity because it is so reliable. It can burn for long spans without noticeable change, and it can be powered by grids that reach across regions. And still, sometimes, the presence of light is felt most clearly when it is limited. A candle on a table does not make everything bright. It creates a gentle gradient. It makes the nearest surfaces warm in tone and leaves the far surfaces soft and indistinct. It makes small movements visible and makes large spaces feel calmer. This is one reason candles remain, even when they are no longer needed for daily illumination. They offer a kind of light that does not pretend to be day. They offer a small local brightness, like the early nights around fire, like the first lamps in clay, like the first dipped wicks in tallow, like the first careful beeswax tapers. In the long history of light, there is an ongoing conversation between darkness and control. A flame is controlled darkness. It is a chosen interruption in the night, a shaped opening. As lighting technology grows more powerful, the opening grows wider. Streets glow, factories glow, homes glow with the press of a switch. The night becomes less of a boundary. But the older forms, candles and small lamps, keep the boundary near. They keep night as a presence. They allow darkness to remain around the edges, and in that way they preserve an older pattern of attention. In quiet rooms, in many centuries, a single flame could be enough for a small task. A person might bring a lamp close to a page, or bring a candle close to needlework, then set it back again. The movement of the light source becomes part of the movement of the body. The light is not uniform. It is negotiated. In that negotiated light, objects appear one by one. A cup rim catches a highlight. A page shows a thin field of brightness. A wall shows a faint, trembling pattern. The flame itself, if seen directly, is never still. It bends in drafts. It lengthens and shortens with the fuel supply. It carries a small sound, sometimes almost nothing, sometimes a soft flicker. In pre-electric homes, the daily light might begin with morning sun and end with a fire's embers and a candle's last inch of wax. In those homes, the timing of sleep, the timing of meals, the timing of work could be closer to the available light. When gas and then electricity spread, those patterns loosened. Evening hours grew easier to fill with activity. Streets became safer to navigate at night in some respects, simply because they were brighter. Shops could remain open. Newspapers could be read later. Letters could be written at night without leaning so close to flame. Still, the candle remains, patient and unchanged in its basic nature. Wax, wick, flame. Even the word candela used now in scientific measurement, keeps the old root of candle. The language holds the earlier object inside the modern system, and it can be calm to stay with the earlier object for a while, because it moves slowly. A candle consumes itself in a steady way. It does not rush. It makes time visible as wax softens, as a small pool forms around the wick, as the candle's top edge lowers, almost too gradually to notice. Across centuries, that slow consumption happened in countless rooms. It happened in kitchens beside bread and bowls. It happened in workshops beside wood shavings and cloth. It happened in libraries beside paper and ink. It happened in places of worship beside stone and singing. It happened in ships' cabins, protected in lanterns from wind and motion. It happened in city streets, in larger arrays of lamps, where flames multiplied and became a pattern. Even when electricity arrived, candles continued in places where wiring did not reach, or where fuel and flame remained more practical. Kerosene lamps continued too in many regions, bright and familiar, with their own glass chimneys and steady draughts. Gas lamps continued in some streets and homes for long spans, even after electric grids expanded. And in the background, the sun continued to rise and set, still the largest light, still the original schedule. Light in that sense has always had layers. Daylight, firelight, lamplight, candlelight, gaslight, electric light, LED light. Each layer adds a new way of extending vision and time, but none fully erases the earlier ones. Instead, the earlier ones become more symbolic, more occasional, more chosen. A candle can be lit for ceremony. A candle can be lit for scent. A candle can be lit for quiet. A candle can be lit when electricity is absent. And once lit, it begins the same quiet process it has always begun. Heat rising, wax softening, a small pool forming, a wick drawing upward, a flame shaping itself into a small, bright point. In that point, the long history is present without needing to be named. The clay lamps of ancient shores, the dipped rushlights, the Roman wicks in tallow and beeswax, the medieval chandlers measuring and moulding, the careful trimming of wicks, the small metal scissors, the steady practice of keeping smoke down, the chemistry of purified fats and waxes, the argon chimney drawing air, making a brighter flame, the city gas network bringing flames to streets, the clear kerosene in a lamp reservoir, the bright arc light at a distance, the warm filament inside glass, the power station feeding a grid, the glowing diode, small and efficient. All of it returns softly to the same simple scene. A room, darker beyond the edges. A small light near the center. A slow movement of flame. Not dramatic, only persistent. A light that does not insist. A light that makes a little space for sight and leaves the rest of the night undisturbed and keeps burning in its own small rhythm, drawing fuel, giving warmth and glow. A thin thread of brightness held in air, and then leaning slightly, and then straightening again, and then settling into the steady work of being a flame, quietly, gently, and without any need to hurry, as wax continues to soften and travel upward, and the flame continues to hold its place, and the surrounding shadows continue to rest where they are. and the light continues to fall on nearby surfaces, and then fall away, and then fall away a little more, until only the closest edges are clear, and everything else becomes softer, and the brightness remains small and constant and unremarkable, and the candle continues, and the story of light continues with it, unforced and slow and steady and calm and gradually quieter, like an old evening that does not need to be finished, only to keep going, moment by moment, with the flame simply doing what it does, and the darkness remaining spacious around it, and the hours moving on in a way that does not need to be marked, except by the very gentle lowering of wax and the very gentle tremble of light.